Determinant. I am H.G.TIWARY, Supervisor Head of DMCCL Grady. I am going to teach determinants. What is determinants? What, what is the process of evaluation of determinant? What is minor? And what is cofactor of elements of determinant? Properties of determinant. Then how to solve problem of a determinant. So it is an important topic according to the CBSE question paper. So student, a determinant is also an arrangement of elements or functions which are written in the form of rows and column. A determinant has a fixed value, whereas a matrix has no fixed value. No fixed value. It is only arrangement of elements. Student, determinant is also an arrangement of elements which are written in the form of row and column. A determinant has fixed value, whereas a matrix has no fixed value. It is only arrangement of elements. Further, a square matrix has its determinant, but the matrix has no its determinant. Only a square matrix has its determinant. Now, suppose A is a square matrix 1, 2, 3, 2, 2, 1, 4, 5, 6, 3 rows, 3 columns. It is a square matrix. So, it has a determinant. It is denoted as determinant A, or DTA is equal to, this symbol will change, this big bracket, it will be this in this way, 1, 2, 3, 2, 2, 1, 4, 5, 6. It is a determinant of this square matrix. If B is a square matrix A, B, C, D of 2 by 2, then its determinant B or DTB we can write in this way, A, B, C, D 2 by 2. So any square matrix has determinant. Now student, how to evaluate a determinant? कैसे इसका evaluation करेंगे? First of all, we see of order 2, then order 3, evaluation of a determinant. So, a determinant, if A is a determinant 2, 1, 3, 2, 2 by 2, so how can you evaluate this? Here we multiply this and this first. First we multiply this and minus multiply this. So 2 into 2 first you write minus 3 into 1. So 4 minus 3, 1. This is the evaluation of determinant of order 2. This and this, first these two are multiplied minus this into this. So this is the thing. Now we will study sign convention of a determinant. Suppose a determinant A is A11, A12, A13, order 3, A21, A22, A23, A31, A32, A33. It is a determinant of order 3. So, sign convention. Student, you see it is the element of first row and first column. So 1 or 1, 1 plus 1, 2. So before this sign will be positive. Here 1 plus 2, 3, odd number. So before this sign is negative. Here 1 plus 3 is odd. So sign will, 1 plus 3, 4 is even. So sign is positive. Here 2 plus 1, 3 is odd, so minus. Here 2 plus 2, 4, even number, so plus. So it is minus. Here 3 plus 1, 4, even, so plus. 3 plus 2, 5, odd number, so minus. 3 plus 3, 6, even number, plus. So, according to this, we can write here determinant A, sign convention, plus, minus, plus, minus, plus, minus, plus, minus, plus. This is the sign convention. It is useful in evaluation of determinant. So if you want to evaluate a determinant of order 3, 1, 2, 3, 2, 2, 1, 4, 5, 6, 3 into 3, it is a determinant. So, you can evaluate this. Here is a first row, first column. We can write 1, we take. Then this row cancel. This column cancel. This row cancel, this cancel. So, 6 to the 12 minus 5 into 1. This one. So, minus 2. This 2 lies in first row and second column. So this row and this column cancel. 6 to the 12 minus 4 plus 3. This cancel. 5 to the 10 minus 8. So 12 minus 5, 7. 12 minus 4, 8. 16. And 10 minus 8, 2, 6. So 13 minus 16, so minus 3. This is the value of determinant A. This is the process of evaluation of a determinant of order 3. So, in this way we can evaluate a determinant of order 2 and order 3. Now student, you should have concept of minors and cofactor of elements of a determinant. So, as for example, student, concept of minors and cofactors. Suppose a determinant is A11, A12, A13, A21, A22, A23, A31, A32, A33. It is a determinant of order 3. So if we have to find minor of A11, how we can find minor? Student, minor of element A11 represented M11, and this row will be deleted and this column. So we are getting A22, A23, A32, A33. So if you multiply this into this, so minor this into this, so A22 into A33 minus A32 A23. So this is the M11 minor of A11. Similarly, M12, we can cancel. A12 lies in first row and second column. So you delete this and this. So we have A21, A31, A23 and A33. So if you multiply this, simplify A21 into A33 minus A31 into A23. This is the minor of M12. In this manner, we can find minor of each element of a determinant. This is the way of finding minor. Now, student, how to find cofactor? So, student, cofactor, for cofactor, element of A11 is noted as C11, and it will be here minus 1 and 1 plus 1, 2, M11. Yani M11 is multiplied by minus 1 and 1 plus 1, 2. This is the cofactor of A11. That is C11 is equal to, we have A22, A33 minus A32, A23. Similarly, cofactor of A12, C12, it will be minus 1 power 1 plus 2, 3, M12, that is minus M12, that is M12 is A21, A21, A23, A31, A33. So if you multiply this, minus A21 into A33 minus A31 into A23, this will be, so if you remove the bracket, A31 into A23, A21 into A33, this is the C12. So, in case of A12 cofactor C12, here is odd 1 plus 2, 3, so minus 1 power 3, so negative sign will be before the minor. So, this is the way to find cofactors of elements of a determinant. So student, minor and cofactor clear. Now we have to study properties of determinants. This property will be helpful in solving the problem of determinant. So one by one I am going to discuss about properties of determinant. Of determinant. First property, if a determinant A 1, 2, 3, 2, 2, 1, 4, 5, 6, it is determinant, then if we interchange row into column, then we are getting a determinant transpose change 1, 2, 3, first row, first column, second row, second column, third row, third column. We are getting this. We can see that both the value will be same. Determinant A is equal to determinant A dash. We can see. We can prove this also. Proof. Determinant A is 1, 2, 3, 2, 2, 1, 4, 5, 6. Now evaluate this. 1, this cancel, 12 minus 5, here minus 2, this cancel, 12, 12 minus 4 and plus 3, this cancel, 10 minus 8. So 12 minus 5, 7, 12 minus 4, 8, 8 to just 16, and 10 minus 8 to 6. So 13 minus 16 minus 3 is the determinant of the. Now we find this value. Transpose of this determinant, we can find value 1, 2, 4, 2, 2, 5, 3, 1, 6. Evaluate this, you can see 1 is there. So this cancel, 12 minus 5 minus 2, this cancel, 12 minus 15 and plus 4, this cancel, 2 minus 6. So 12 minus 5, 7, minus 2, 12 minus 5 minus 3. So 4 into minus 4, it will be minus 4. So 7 plus 6 minus 16, 13 minus 16 minus 3. So what are observing student? We can see that determinant A is equal to determinant A dash. Both in this case, both the value will be same. So by interchanging the row into column, value of determinant is same. This is the first property. Second property, student, second property, if we interchange any two rows or columns, if we interchange any two rows or columns of a determinant, then its absolute value will be same. absolute value will be same, but sign will be changed. But sign will be changed. So if I am taking example determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. It is a determinant of order 3. It is R1, it is R2, it is R3. It is C column 1, column 2, column 3. If we apply the operation, if we interchange, if R1 here determinant A minus A21, A22, A23 and A11, A12, A13, A31, A32, A33. One negative sign will come before the determinant if we change any two row column. Again we can change. Suppose again we have changed. Again we R2, R3 we do in this way operation, then minus and minus, again minus A21, A23, that is here is A31, A32, A33, A11. This is again we put second negative sign before determinant. So this is the second property of determinant. It will helpful in solving the problem determinant. Now third property, student. Third property of determinant will be third property. If A is a determinant and 1, 2, 3 first row, also second row, 4, 5, 6. Here two rows are same, 1, 2, 3. R1 is also 1, 2, 3, R2, 1, 3. So this is equal to 0. Also the determinant 4, 5, 6, 4, 5, 6, 3, 2, 1. Two columns, elements of two columns are equal. So again this value will be 0. This is the third property of determinant. Now fourth property. Determinant A, first element 1, 2, 3, second 2, 4, 6, 5, 7, 8. Here we see that if we take ratio of elements of R1 and R2, then 1 by 2, 2 by 4, 3 by 6, that is 1 by 2, 1 by 2. It is proportional. So value of determinant will be 0. Value of determinant will be 0. So if elements of any two row or columns are proportional, then value of determinant will be equal to 0. Now next fifth property, student. A determinant if elements of any row or column of determinants are expressed as sum of sum of two or more term, then determinant can be expressed as sum of two or more determinants. And for example, I am going to give an example before you. If determinant A B1 plus beta and C1 plus gamma, this is the first row element, A1 plus alpha, B1 plus C1 plus gamma. So it is A2, it is B2, it is C2, A3, B3, C3. Then this determinant, here we see in first row elements are represented as sum of two terms. So we can express this determinant as sum of two determinant, that is A1, A2, A3 first column, B1, B2, B3 second column, C1, C2, C3 third column, and plus first row will be alpha and beta, gamma, A2, B2, C2 second row, A3, B3, C3. So we can express as sum of two determinant because here elements of first row are expressed as sum of two term, so it will be expressed as sum of two determinant in this manner. So this is the fifth property of determinant. Now student, sixth property of determinant. Six is this, is A11, A12, A13, A21, A22, A23, A31, A32, A33. So if each element of a row is multiplied by k, then this determinant will be divided by k. If we multiply each element by k, ka11, ka12, ka1, ka13, ka21, ka22, ka23, ka31, ka32, ka33, where k is not equal to 0, then we have to divide this determinant by kq. Then we have to divide this determinant by kq. So this is the thing. If we multiply this by k, this by k, this by k, then we have to divide this by kq. Now, if a matrix we have matrix, it is a matrix, then determinant of Ka will be Kq into determinant A. According to this property, it will be Kq into determinant A. Now, seventh property of determinant, suppose it is a determinant student A11, A12, A13, A21, A22, A23, A31, A32, A33. As per need, we can apply operation to get anything common in row and column, or any elements will be, to make any element 0 in row and column, we can add and subtract, we can write operation R1 change R1 plus R2 we can do. So determinant is equal to A11 plus A21, A12 plus A22, A13 plus A23, A21, A22, A23, A31, A32, A33. We can do in this way. Also, we can write, we can subtract also. Suppose a determinant A11, A12, A13 so as per need we can do R2 is change into R2 minus KR3. We do in this way. Value will be same. A11, A12, A13. Here R2 is changing. So here it will be R2 minus, so A21 minus K, A31, A22 minus K, A32 and A23 minus K, A33. We can apply this property to make something common in any row or to make elements of any row and column zero. This property is very useful for simplification of determinant. So it is a very useful property. Now last property, eighth property of determinant. I want determinant A is A11, A12, A13, A21, A22, A23, A31, A32, A33. So in this case value of determinant A will be A11 into cofactor of this C11, A11 into cofactor of C11 and A12 into C12 and A13 into C13. This will be equal to value of determinant. But if A11 into cofactor of this C21 other rows के cofactor other element के and A12 into cofactor of C22 and A13 cofactor of C23, it will be equal to 0. Then value of determinant will be 0 when we take this element and cofactor of other row element, this element and cofactor of other row element plus this into cofactor other element, this value of determinant will be 0. So these are the 8 property of determinant, students. With the help of this, we can solve the problem of determinant. In the board examination, 4 marks question has been asked in the CBSE examination. Usually I have seen every year 4 marks question has been asked in CBSE examination from this chapter. So this chapter is important in view of CBSE examination. Thank you.